So, good evening, everyone. I welcome you back to my YouTube channel. Presenting before you this wonderful tutorial is the mentor Hampir Kliman. Are you in distress because possibly you don't know how to find rational functions? Do you feel like you are in a mathematical ICU? You feel like maybe when you're given a question under rational functions, you won't be able to solve anything. And be it given 10 marks, you feel as though you get 0 or nothing. Why? Because you never knew how to sketch questions under this particular topic. If you are such a one, pay attention. Let me help you. So this is the easiest concept on how to solve every question under rational functions. We have been given a question saying let f be a function defined by f of x is equal to 3x to the power 2 plus 1 over x to the power 2 minus 4. The first question is saying we find the domain of the function of f of x. This is very simple because the domain implies all values in the x-axis. To solve A, I will just get what is in the denominator minus 4 and equate it to 0. Then x to the power 2 is going to equal to 4. This is going to be squared and squared, and my x is going to be negative 2 or positive 2. If I put this on the real line, I'm going to have negative infinity, also positive infinity on the other end. So this is going to be a negative 2. This is going to be a 2. Okay, so I'm going to get values here, values here, values here, and my domain is going to be coming from negative infinity all the way to negative 2. Okay, all the way to negative 2. So of course, this must not equal 0. Okay, must not equal 0, must not equal 0. So to negative 2 not included, the union of negative 2, then 2, then the union of 2 to positive infinity. So this becomes your domain for this particular question. It's actually very simple. Okay. Now the question comes up and says, find the vertical and horizontal asymptote, if any. Okay, so there's a possibility that you could not actually have some of them. Okay, but you just have to find. So for B, they are asking us to find the horizontal and vertical asymptote. So the function of f of x is equal to the vertical and horizontal asymptotes are very important because they will help us to graph and bring out the sketching. Now look at this. Look at this. Look at this. We have x to the power 2. This is a minus 4, right? We want to find the vertical asymptote. Get what is in the denominator, so you're finding the domain. So this is x to the power 2 minus 4 and just equate it to 0. Okay? Then this is going to give us x to the power 2 equal to 4. Square root of this, square root of that. If we cancel, our x is going to equal to 2 or negative 2. So our vertical asymptote is going to equal to 2 or negative 2. Okay, let's do horizontal asymptote. Our horizontal asymptote, we just look at the degree of the x value given. So because it's a power, it's x to the power 2 there, and then on the other end is also x to the power 2. So that is just like, of course, this is going to be like, this is x, this is 3x to the power 2 over x to the power 2, like that. Okay, so that is what we That is what we have there. Now, we want to find the horizontal asymptote. Okay, so you just look at the degree of, you just look at the degree of your powers of x, and your horizontal asymptote becomes a 3. So that is the horizontal asymptote. The question further goes on to say, sketch the graph and hence state its range. This is what I want. How do you sketch the graph? Simple. Get your vertical asymptotes. So I'm going to get my vertical asymptotes. Simplest concept, get your vertical asymptotes always. So my vertical asymptote, I have 2. And then on the other end, I also have -2. Then get at least 2 values greater than 2. So I'm going to have a 3, a 4. Even below, values that are less than 2, I'm going to have 1, and then I'm also going to have 0. Even this side, 2 values above -2, so this is going to be like -1, and then 0, and then values below -2, this is going to be like -3, -4. Then you're going to create something like this. This is going to be your x, this is your y. So this is going to be like 4, 3. I'm going to get these values here. Then 2, 1, 0. So already have 0 here. Then I'm going to say -1, -2, -3, -4. These are you plot every rational function given any question. Then you get 4, you insert it in the equation. Okay, so when you put 4 in there, what are you going to get? Okay, so let me try. If I put 4, this is going to be like this is going to be like a 4 power 2. Then this is going to be like -4, right? Then this is going to be 3, then 16 plus 1 over 16 minus 4. So this is going to be like 3 multiplied by 16, 48, plus 1 over 12. So 48 plus 1, it's 49, divided by 12, it's 4. So if I put 4 there, I'm going to get a 4. If I'm using 3, if I insert that, okay, already tested, you're going to get something like 5.6. If you're using 2, you won't have anything. It won't work because you have 0 in the denominator. If you're using 1, you're going to get -1.3. Okay? You're going to get -1.3. If you're using 1, you're going to get -1.3. If you're using 0, you're going to get, let me try. So if you're using 0, it's going to be 0 there, 2, then plus 1 over, then 0 there, then -4. So this is going to be like -1 over 4. So this is -1 over 4. Okay. If you're using -2, you won't get anything. If you're using -3, you still get 5.6. If you're using -4, you still get a 4. Now, after you bring out these values, there is one important thing that you should never forget. Y-intercept, x-intercept. Let's go. Okay. So after you bring out those points, you now go to your x-intercept. X-intercept is found when y is equal to 0. So meaning I'm going to put 0 in the function like that. This is going to be 3x to the power 2 plus 1 over x to the power 2 minus 4. If you cross multiply, you have a 0 is equal to 3x to the power 2 plus 1. This is going to be negative 1 is equal to 3x to the power 2 over 3 over 3. X to the power 2 is equal to negative 1 over 3. So no solution. So there is no x-intercept. Let's do y-intercept. Please just bring out what I am teaching right now and you'll be able to plot anything. Okay, so this is found when x is equal to 0. And your y-intercept okay, your y-intercept is going to be minus 1 over 4. It will even help us to find the range. Okay, now we have brought out everything that we wanted. Just this, it will help us to plot what we want. Okay, so I'm going to create my graph. Okay, you plot your graph. So I'm going to have 0. So my highest value in the y is 5.6. Okay, so I'm going to say 1, 2, 3, 4, 5, 6, 7. 1, so in negative, negative 2, negative 3, negative 4, negative 5, negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Now, let's plot what we have. Look, even when you look at the equation itself, it's y is equal to 3x to the power 2, right? Plus 1 over x to the power 2 minus 4. Already, you have an idea that your graph is going to look like this. Okay? Because you have x raised to the power 2. Please, you should take note of these concepts. Okay, you'll see even the graph itself will be able to tell you when it comes out. So now let's do this. The first coordinate is 4, 4. 4, 4, it's here. This is 4, 4. Good. The second coordinate is 3, 5.6. 3, 5.6. Okay, it's here. So before you even go any further, you need to plot your vertical asymptotes first. So what is a vertical asymptote? It was negative 2 and positive 2. So you bring them out. Okay, you bring them out like that. Then you also draw your vertical asymptote here. What is your horizontal asymptote? It was 3. So you're going to draw your 3 here, your line at 3 like this. Then the first point was 4, 4. So 4, 4 was here. So already this point gives you the graph that you want. Okay? It already gives you the graph that you want. So this is going to be our graph. Okay? We go to the other one. Three, 5.6. 3, 5.6 is here. So ignore, because you've already, it's even this one is giving you the area in which you must shade, but you've already shaded that point. So you forget this one. Okay? You forget this one. You're just trying to see how the graph will behave. 2 is not there. 1 comma negative 1.3. Okay, that is, you go 1 comma negative 1.3. So negative 1.3. This is 1 comma negative 1.3. So 1 comma negative 1.3 is supposed to be here. Okay, so you shade that point. You don't know where it's going, so you leave it. You go 0 comma negative 1 over 4. So 0 comma negative 1 over 4. 1 over 4 is the same as 1 divided by 4, 0.5. So this is going to be the point. You see? So already it's now showing you how it's going to flow. Then you have negative 1. Negative 1 is giving you negative 1.3 also. Okay, negative 1 will give you negative 1.3 also. Okay, so you go on your graph, you check. Okay, so negative 1 will give you negative 1.3. So it's here. Okay, it's here already. It's already coming out. Then you go 2. Negative 2 won't give you anything. Negative 3 is giving you 5.6. You go negative 3 is here, 5.6 is somewhere here already. Even this one also gives you the graph that you desire. Okay, we can draw it either here. Okay, like that. Okay, then we go to our graph again. Okay, the negative 4,4. Negative 4,4 is this graph here. Okay, still is in the same region where we're supposed to plot, so no need, we ignore it. Now we have a graph. These points, how do we connect them? So these ones will be going downward like that. This one will be going downward like that. And that is how you plot this particular graph. Okay, so the range, for the range, you can calculate it if you want. Okay, you can calculate it. But you check where the graph is cutting. You discover that this graph in the y-axis, it's cutting at some point, negative 1 over 4, or it's going downward. When it's going up, it's cutting at 3. So your range is going to come from negative infinity all the way to negative 1 over 4, the union of, then it reaches at 3, it starts going upward. So 3 not included, all the way to positive infinity. This is how you solve this particular question, and you get your 8 marks or 10 marks for this. Thank you so much.